Hello, greetings, and welcome. Let's take a look at our third critical path method example. So, a company is in the process of preparing a budget for launching a new product. The following table provides the associated activities and their durations. Use the forward path to calculate the earliest possible starting and finishing times of all activities. Use the backward path to calculate the latest allowable starting and finishing times of all activities. Calculate the total floats of all activities, and determine the critical path. Okay, so let's do it. So just as before, I'm going to do this in two steps. In the first step, I'm just going to use the information in the first two columns to draw a network to make sure I get all of the precedence relationships correct. And then in the second step, I'll essentially take that network but replace the nodes, which are just circles and labeled as the activities, and I'll use the 3x3 grid, which is recommended in the text, where the first column will contain information with regards to the earliest possible starting and finishing times. The last or the first row will contain that information. The last row will contain information on the latest possible starting and finishing times. The middle row in the middle will be the activity, and then next to it will be the float, which we'll calculate in the end. Okay, the first step might be unnecessary. For me, I have found it useful in terms of first making sure I have all the interconnections right before I draw my final diagram. Okay, as we get better and better, that first step may be completely unnecessary, but for now, I'm going to take the extra couple of minutes and use it just to make sure I have everything right. Okay, so as I set up my network, right, I start with some initial source node, and then I'm going to end with some final terminal node, just to make sure that my network begins and ends at a single point. Okay, or I guess at a single node. All right, so looking at my activities and immediate predecessors, I see that A and B have no immediate predecessor. Okay, so I can draw my A node and B node. Okay, and I can begin those immediately, so I can connect those directly to my starting node. Okay, then activity C, okay, has a predecessor of just A. D has a predecessor of just C. E has a predecessor of D. Right, so these activities are performed in a series. Then F is going to be dependent on F and E, or B and E. So let's just say F, okay, and F is going to be dependent on E and B. Okay, so it has a predecessor of E and B, so I'm going to connect both of those. So we'll get the whole fact that both need to be completed when we do our forward and backward pass in terms of the timing. And then G is going to be dependent on E and F. So I'll have G, which is dependent on E, or has a predecessor of E and F. And then that's it. So I'm going to draw my terminal node. And what I'm making sure is that each node has some sort of outgoing path or terminal path. Okay, so all do except G. So it's G that I'm going to tie to my terminal node. Okay, cool. All right, so now that I have the basic layout and connection right, I'm going to go back and redraw this, but using this grid notation recommended in the text. Okay, that I can do a little better drawing a circle. Okay, so for A, okay, I'm going to have my 3x3 grid. Okay, in the middle is going to be my activity. To the left of it, that's going to be an empty cell. So I'm going to go ahead and draw A and B. Okay, and I'm just going to draw on all these nodes. And then once I have that, I'm going to draw the interconnects. No real rationale for that, besides when I start drawing in my interconnects too, my pictures sometimes have seemed to have gotten a little sloppy when I've gone in that route. Okay, so I'm going to try and follow the setup that I have there for my basic network. So we had E. And F. G. And then a terminal node. Okay. So my source is connected to A and B. B gets connected to F. A is connected to C. C is connected to D. D is connected to E. E is connected to F. F's connected to G. E is connected to G. And then G was connected to my terminal node. Okay, cool. So next, I'm going to go to my table and I'm going to add to these nodes our duration. Okay, so A is 10, B is 7. So A is 10, B is 7, C is 5, and D is 3. So C is 5, and D is 3. E is 2, and F is 1. 2 and 1. And finally, G is 14. Okay. All right, and if you wanted to, you could, look back at what these are described as. But in the interest of this video, I'm just taking them as A through G. Okay. All right, now I'm going to do my forward pass. So I'm going to change my ink color to red. And so the way we do this is we start by initializing our project. Right, our project's going to begin at time equals 0. Okay. All right, so starting from my initial node or my starting node, okay, I go to A or B. Okay, so the earliest possible starting time for A is going to be 0, has a duration of 10. So the earliest possible finishing time is 10. For B, earliest possible starting time is 0, has a duration of 7. So earliest possible finishing time is 7. Okay. C has a predecessor of A, so C is dependent on A. So the earliest possible starting time is 10, has a duration of 5. So earliest possible finishing time is 15. Okay, so following along, D just has a predecessor of C. So it's going to have an earliest possible starting time of 15, has a duration of 3. Earliest possible finishing time is 18. E is only dependent on D, so E is going to have an earliest possible starting time of 18, duration of 2, so earliest possible finishing time of 20. Okay. And then from there, okay, I need to go back, and B is connected to F, or F's dependent on B. So the earliest possible starting time for F. Okay, so now F, okay, F's dependent on B and F's dependent on E. So what I'm looking at is the earliest possible finishing times of all predecessors. Okay, so all of my predecessors, so that's B and E. B has a earliest possible finishing time of 7, E 20. Okay, so I'm looking at the maximum of those values, because if both of those need to be completed in order for F to begin, what I'm going to be held up by is the one that finishes the latest. Okay, so taking the maximum of those earliest possible finishing times, so the earliest possible starting time of F is 20, has a duration of 1, so earliest possible finishing time is 21. Okay. And then if I look at G, G has an immediate predecessor of both E and F. Okay, so again, I'm looking at the largest, the max of those earliest possible finishing times. So that's going to be due to F. So the earliest possible Starting time of G is 21, has a duration of 14, so that's going to be 35. Okay, and then I just go from G to my terminal node. So this whole process then will take 35 days. Okay, so the whole process will take 35 days. Now I perform my backward sweep. Okay, so I know this process will take 35 days. Okay, so now working backwards, so G, which is the only process connected to my terminal node, its latest possible starting time in order for my project to end on time, 35 days is 35. So it's a duration of 14, so therefore the latest possible starting day is 21. Okay, so now moving backwards, let's proceed. Okay, and so I slowly look at these things just to make sure I have them right. Okay, so G has a predecessor of F. Okay, so F needs to be completed in order for G to begin. So if G needs the latest possible starting day is 21, the latest possible ending day for F is day 21, has a duration of 1, so the latest possible starting time or day is 20. Okay, G is also dependent on E. So if G, its latest possible starting date is 21, the latest possible ending date of E is also 21. It has a duration of 2, so the latest possible starting date of E is 19. Okay, so going backwards, so let's go from F to B, because so F, hold on, I got to make sure I've got this cycle right. So G is dependent on F, so F has to end on day 21. G is dependent on E, so E needs to be end by 21. Okay, and as I go through this cycle, yeah, this is good. This is okay, right? So no, this isn't okay. So this one's a little complicated because F is dependent on, so G is dependent on F, so F needs to end on day 21. Okay, but F is also dependent on G or on E. So E actually needs to end on day 20. Okay, I need to make sure I get all these. So I need to get all these relationships right. Okay, so if I follow this back, okay, G is dependent on F. So F needs to end on day 21 at the latest. Okay, but F is dependent on E. All right, E needs to be completed before F does. So if the latest possible starting date of F is 20, then the latest possible end date of E is 20, which gives it a latest possible starting date of 18. Okay, so then going backwards, boy, so this is so good. So then going from F to B, if F needs to begin at the latest on day 20, then B at the latest needs to end on day 20, has a duration of 7, so it needs to begin at the latest on day 13. Okay, going from E to B, so the latest possible starting date then of D is 18, duration of 3, has to begin on day 15. C then, latest possible end date is 15, duration of 5, has to begin on day 10. And then C to A needs to end on day 10, has a duration of 10, so it needs to end on latest possible starting date is 10. Okay, so then if I calculate my floats for A, the earliest and latest possible starting dates and ending dates are the same, so I have a float of 0. Same is true for C. Same is true for D. Same is true for E. Okay, same is true for F, and same is true for G. Okay, when it comes to B, I find that I have a difference of 13. Okay, so I actually have a float of 13. Okay, so in terms of critical activities, A, C, D, E, F, and G are all critical. Right, so F was dependent on E and B, right? F is dependent on E and B, and G is dependent on E and F. Okay, so A, C, D, E, F, and G are all critical. Well, B has a float of 15. Okay, so my critical path will be A, C, D, E, F, and G. So what that tells me is that activities A, C, D, E, F, and G all need to begin and end at the specified times for this project to be completed on time. Any delay in any one of those activities will delay the project. B, on the other hand, has a float of 13 days. Okay, so as long as I begin B between day 0 and day 13, there'll be no delay to my project. Okay, so critical path A, C, D, E, F, and G, all of those activities are critical and need to be completed, started and completed on time. B, on the other hand, is a float of 13, so I have a window of 13 days during which that project can start and finish. Okay, excellent. Hope that helps.